Hi everyone, I hope your semester is going well. I know that you must be excited to get started with the Halloween celebration this weekend. Just make sure that you have a safe celebration and you're following all the social guidelines that are, put there by NKU or even like your state government as well. So I wanted to take this opportunity to record the video and tell you a little bit more about the class that I'll be teaching in the spring semester. So this class is called Structural Geology. So this is a 4 credit class. So if you're a geology major, this is one of the core classes that you need to take to graduate. So again, this class has both lecture as well as lab. I'll be teaching this class in person, face to face in the spring semester, hoping that the situation that we are currently in improves in the spring. If things don't change, I may have to actually at least turn the lecture online and have like labs face to face. We're also gonna have 3 field trips in this course. So one field trip will be traveling to Lexington to look at one of the rock outcrops. The second field trip will be to Red River Gorge. I know that some of you may already have gone there. So we will do that trip in combination with Geology 420, which is stratigraphy class that will also be offered in the spring semester. And our big field trip, so that will be 3-day long field trip, will happen in along the road cuts in West Virginia. So if you have gone to Appalachian Mountains, those are like some of the beautiful places to study structural geology. So we'll spend like a lot of time kind of like looking at some of those rock outcrops along the road cuts in Appalachians. So that will be in West Virginia. So let me kind of like tell you a little bit more about the class that I'll be teaching in the spring. So obviously, if you have taken Geology 110, if you have taken Geology 120, you may have studied the concept of plate tectonics, right? So in the plate tectonics, obviously, you may have studied like how the Earth's lithosphere is kind of like divided into like multiple tectonic plates, how those tectonic plates move related to each other, and how their movement kind of like deforms the surface of Earth. So to understand the difference between structural geology and tectonics, in structural geology, we typically focus on the shape and the internal structure of the deformed rocks, which means if you are looking at rock that is being deformed or has been deformed over time, so how can we actually identify what type of deformation has happened within the rock? How can we even identify or quantify that deformation? And even like trying to understand the different geologic processes that have happened in the past and how they influence the deformation rock at not only at the microscopic level, but also at the regional scale as well. So in structural geology, we deal with the shape, the internal structure, as well as the processes that are responsible for the deformation of the rocks. In tectonics, obviously, we look at these processes from much more global or regional perspective. So again, the question is, okay, why one should study structural geology or even tectonics, right? So there are like a lot of areas where we look at the rocks from a structural geology perspective, right? So when you think about Earth, like we know that Earth actually started forming 4.6 billion years back. So a lot of things have changed in terms of the surface features of Earth. So if you go outside and if you look at like the mountains, if you look at the rocks that are like even around in Kentucky, you will see that at the local level, you may think that the rock is not deformed, or you may think that the rock layer that you see around you may not be deformed. But if you look at the same rock layer from much more regional or broader perspective, then you will see that that particular rock layer or even a rock is a part of a bigger deformed body, right? So, like I said, the tectonic plates have been moving on the Earth's surface for a long time. The Earth is being deformed for a long time. So there is not a single rock that is sitting just on the Earth's surface undeformed. So, which means these processes are that have happened in the past are still happening today's time. So we need to understand them to even like figure out, okay, what was the reason that particular rock body deformed. So if you're taking, for example, class like stratigraphy, where people study um, the rock depositional features, you need to understand the concept of structural geology, because in this class we'll be talking about features like faults or folds, right? So synclines and anticlines. So obviously those features will also influence how different sediments get deposited, how even different environments form uh, within different structures, right? So if you think about anticlines, right? So anticlines are basically more like mountains, right? So you're not going to have formation of a lake along an anticline, right? So typically lakes or oceans will form in the places like synclines. So structural geology can influence the way depositional processes operate on the surface of Earth. Sedimentology, right? So where we kind of like look at the features of sediments, right? So their thicknesses, for example. So structural features of rocks can influence how fast or slow sediments gonna deposit, like even like the thickness of the sediments as well. Because if you go to places like anticline where they look like mountains, right? Typically you will see like a lot of rock layers that are being eroded away. So those are the places where you find a lot of unconformities. If you go to places that are called synclines, like low-lying areas, right? So that where all the sediments gonna come and then they're gonna get deposited. So typically you'll find like nice and thick rock layers in the places like synclines. So synclines, anticlines, faults, folds, these are like the structural features that can also influence the deposition rate of the sediments as well. So it is really good to know about these features studying sedimentology. Things like petrology, in petrology, sorry, obviously you'll be studying different rock materials from their compositional perspective, right? So you have igneous petrology, you have metamorphic sedimentary petrology. So when you think about rocks, obviously different rocks have different composition. Even like, if you think about igneous rock, there are different types of igneous rocks with different types of minerals, and their composition can change. So the composition of rock can also influence the way those rocks get deformed, right? So igneous rocks get deformed differently than sedimentary rocks or even metamorphic rocks, right? Even within the sedimentary rocks, to make things a little bit more complicated, shale, claystone, right? So these are much more ductile. So they get deformed differently than limestone or sandstone, which are much more brittle. So in structural geology, we sort of try to understand like how the composition of rock can also influence the way those rock bodies get deformed over time. Geophysics, right? So if you work in industries like oil and gas or even geotechnical industry, we need to understand whether there is a feature in the subsurface that's going to cause problem, like earthquakes, right? So if you have a fault under your house, obviously if you're building a house above a fault, it is likely that at some point that house will collapse if the fault is active, right? So we need to sort of like take geophysical data and try to understand if those structural features exist in the subsurface as well. So in geophysics, people use structural geology or understanding of structural geology to identify different hazards, like at a much more global perspective, like earthquakes obviously are much more global phenomena. So if you want to like understand the type of convergent margin you're looking at, or a transform margin you're looking at, so you need to understand what are the different features associated with the convergent margin. So that also like comes under structural geology, because those features are interacting in a dynamic environment. So they're also controlling how a one particular earthquake is going to happen or is going to influence the surrounding features as well. So again, this is just another example, San Andreas fault, which is what we call a strike slip margin. So if you know like how that particular area is being deformed, you can quantify or calculate like how big of a earthquake can happen along that particular fault. So that is also like what we call like rock mechanics. So this is something that we will also be studying in structural geology, like how stresses get influenced, or how the stresses can decide when one particular fault is gonna get reactivated, or when one particular fault might result into creation of an earthquake. So this is something that we'll also study in structural geology as well. And again, like, if you're studying classes like economic geology, right? So if you may know, like in mining industry, obviously people look for gold, copper, sulfur, those type of economic deposits. So a lot of the times, whenever there is like an intrusion, like plutonic intrusion, you're going to have like a lot of hydrothermal fluids, right? So those hydrothermal fluids typically follow pathways like faults or fractures, right? So that's where you're going to find economically important deposits being deposited. So if you're looking for gold, for example, it is likely that you'll find gold deposits along the faults, because that's where the hydrothermal fluids will kind of like accumulate or move around. So understanding structural geology can help you identify these precious mineral or metal deposits in the subsurface as well. Environmental hazards, right? Sinkholes are also like the things that are very common in Kentucky. So we need to understand like how these type of features are distributed, and also like how much force you need to apply before a sinkhole opens up in the subsurface. So these are like the type of environmental hazards that we'll also be studying in structural geology, obviously from a perspective of the rock deformation. So structural geology is kind of like a foundation science in geology. So a lot of the other areas within the geology are sort of like connected to structural geology. So this figure here, as you can see, it sort of like explains you like how those different areas are interconnected through structural geology. And we have studied like why it is important to study structural geology. So in this class that I'm offering in the spring semester, what is going to be my approach to learn all these things? So there are three ways actually like you can learn these things in my class. So the first way is obviously we'll be looking at from a geometrical perspective, where we'll study like the current shape of the deformed rocks. The second approach is where you will study like these deformed rocks much more like a kinematic perspective, right? So when the deformation is ongoing, that ongoing deformation sometimes results into formation of different types of features within the rocks. So like lineations, myelonites. So that is something that we'll also be studying in this class. And also like much more like from a dynamic perspective, right? So as this like regional or global processes are happening, like plate tectonics, like how those bigger processes can influence the deformation of the rock. So we'll be focusing on the process itself rather than the rock when it comes to dynamic analysis. So in geometric analysis, like I said, we'll be looking at the static features like faults and folds, the concept of stress, concept of strain, like how you can actually measure strain within the rocks that can help you identify what type of deformation has happened within the rock. Obviously, that helps us to understand like how different types of rocks or faults or folds form. So we'll be studying those in detail as well. Then also like we'll study the kinematic analysis of the rocks, which means that we now know like how particular deformed rock looks like. But if you want to understand how it originally looked like and what was the process where it actually moved from undeformed state to deformed states, so this is where we kind of like try to understand the process of deformation itself. So this is kind of like what we call like a balanced cross section, where we kind of like restore a geologic cross section to its original position. And also like I said, much more like from a broader perspective, that this is something what we call like dynamic analysis. So again, in this case, we are focusing on the regional process itself. So plate tectonics, right? So if we talk about, for example, a convergent margin, so what are the different features associated with the convergent margin and how they actually form during that process? So this will be like another approach that I'll be using in structural geology class as well. So like now you kind of like have hopefully some idea about what this class is going to be about. So again, if you have in detail questions, please feel free to like email me. Again, this class has a prerequisite of Geology 110. If you can't meet the prerequisite, please feel free to like send me an email and we can actually have discuss whether this class is kind of like good for you or not. So again, I'm excited to teach this class in the spring. So I hope that I'll see some of you guys in my class next semester. So in the meantime, good luck with your fall semester. Take care. And yeah, I look forward to seeing you in the future. Bye.